Greetings. Today we're going to discuss density. You've already heard the story of Archimedes and the crown, so now you have a better idea of what we are referring to. But now we're going to focus on problem solving. Before I get started, I'm going to ask you the question which probably has been asked of you when you were a little kid. I wonder if a pound of bricks is heavier than a pound of feathers. I wonder. What's heavier? A pound of feathers or a pound of bricks? Think about that for a minute. And of course, I know you know the answer. They're both the same. Obviously, the pound of feathers is going to take a lot more space than the pound of gold, but they're still going to weigh the same. So what's the difference? Well, the difference is that the feathers take a lot more space because they are less dense than the pound of gold or the gold particles. The gold particles are tightly packed together, but the feathers are very well spread apart. The particles are spread apart. All right, so density relates to units. Mass and volume. Mass is the amount of matter, and volume is the space that that matter takes. So we usually refer to mass in grams, and in volume, we're talking about centimeters cubed if it is a solid, or we also can use milliliters for liquids or gases. All right. Now, here's the relationship. Density is equal to mass over volume. Now, let's try to solve this problem. 2.5 kilograms sample of a substance occupies a volume of 250.0 centimeters cubed. All right, so now, to make the problem a little easier, I'm going to convert this to grams. And we know that 1 kilogram is equivalent to 1,000 grams, so therefore this will be 2,500 grams. So I'm going to say 2,500 grams divided by 250.0 centimeters cubed, and that would be equivalent to grams per centimeters cubed, and I recalculated this, and it comes out to
10 with a decimal for the correct number of significant figures.
Grams per centimeters cubed. And if you've already done significant figures, we go with the least, which is this number right here, least number of significant figures. All right, let's go on to the next problem. Find a volume that 35.2 grams of carbon tetrachloride, CCl4, will occupy if it has a density of 1.60 grams. Now, this is a little different. The way that I want you to solve these, instead of trying to remember B, or is it M, is it, what do I multiply by, just do it using dimensional analysis. If I'm given, I know that I have 35.2 grams of carbon, and that I'm looking for the volume. So I'm looking for volume, and the volume is going to be in milliliters. So I'm going to write milliliters. Since I have grams, here's what I'm going to do. I know the relationship between 1.60 grams per milliliters, but I know that I want to cancel out milliliters. So I can flip this relationship. I can write 1.60 grams per milliliters, or 1 milliliter, or I can write 1 milliliter is equivalent to 1.60 grams. So using that, I can put the grams at the bottom so I can cancel them out. So whatever you want at the bottom, you're going to cancel, will be able to cancel. 1.60 grams, 1 milliliter, and you solve this problem by multiplying 35.2 times 1 divided by 1.60, and that gives me
22.0 milliliters, rounded to 3 significant digits.
All right, then I'm going to take a look at this problem, make sure that you remember that whatever's on top, you multiply, whatever's on the bottom, you divide. So grams times milliliters divided by grams. And my grams cancel out, therefore I am left with milliliters. All right, in the next problem, a rectangle block of lead is 2 times 3 times 4.5. All right, so the way to solve this problem, first I have to find the volume of the lead. So I'm going to say 2.0 centimeters times 3.0 centimeters times 4.5 centimeters is equivalent to, I already solved this, it's equivalent to 27 centimeters cubed. Now, what am I given and what do I want to calculate? I want to know what the mass is. And my mass is going to be in grams. So therefore, I'm going to start out with what I have. I have 27 centimeters cubed, and my relationship of density is 11.34 grams per centimeters cubed, or I can say 1 centimeter cubed over 11.34. So in this case, I want centimeters at the bottom, centimeters cubed to cancel out, and I want grams at the top, so I'm going to put 11.34 grams. This is 1, so my centimeters cubed cancel out. I end up with grams, which is equivalent to 306 grams. And I'm going to box in my answer, which is what I want to do. So the mass of my rectangle block is actually 306. Well, there you have it. In class, we're going to practice a lot more problems and get really good at it.